So first we study with this our learning outcomes. Okay, for these topics, we talk about water. Okay, so what we are going to learn here is we need to explain how the hydrogen bonding occurs, which we have already done quite a number of times already, between the water molecule, and relates the property of water to its role. And particularly this property of water definitely relate back to this hydrogen bonding. Okay, and we want to talk about these solvent actions, high specific heat capacity, latent heats of vaporizations. Okay, but even though we always say that these three properties are the main ones, but we do have some other properties that we need to learn. Okay, so generally when we talk about water, we do know that we call the water is not a biological molecule, but we call it a biological medium on earth. So none of us can survive without water. Okay, and all living organisms require water more than any other substance in this world. So we do know that water can exist in three forms: ice in a solid form, water in the liquid form, so steam or water vapor in the gaseous form. Okay, and we do know that majority of the water molecules, okay, exist in the liquid form. You can see that our oceans, our river, our drinking water. So we have to look at what's so special about this water molecule. Okay, let us look at this. Okay, the story, a little bit of the story here before we start our class today. Okay, detail first. Now we learn about this, the interaction force between two particles. If I have two small particles, okay, and we have these two small particles, what they do? They interact with each other. Okay, so they have the interaction. So how strong the interaction it can be between these two particles depends on the molecular weight. Are you clear? Okay, so the smaller the molecular weight or molecular mass, the weaker the interaction. Correct. Okay, van der Waals forces, one of the example, van der Waals forces, or you learn nowadays we call London force, London dispersion force. Okay, so between these two molecules, they always have the interaction. So this interaction, whether strong or weak, it depends on the molecular mass. So generally, if molecular mass is low, the interaction is weak. Okay, now because of this, when the molecular mass is weak, as the molecular mass is small and the interaction is weak, so means that the distance between two particles will be large. Clear? You try to imagine that the person that you didn't contact frequently, you will forget, because why? Distant, right? Okay, so no interaction there. So now, this is an example when you compare between the chlorine versus the bromine gas. It's a bromines. Okay, chlorine gas versus the bromines, and then versus the iodine. In terms of molecular size, then you can see that this one is the smallest among all. This one is the largest. So chlorine actually stay as a gas, bromines in the liquid, iodine in terms of the solids. Why? Because their molecular size. So iodine is the largest molecular size, therefore the interaction will be higher, so they tend to stay close to each other to form solids because of their molecular size big. Oh, sorry, let me draw it big in this case. The iodine. So they tend to have the higher interaction force, therefore they are close to each other, they form solids. Okay, but gaseous state chlorines, their particle is small. So means that the interaction force is not huge enough to bring them close together so they exist as the gaseous form. Are you clear? Okay, so first part, understand the concept here? Understand the concept? The interaction between two particles. Okay, now, next, let us compare between CO2 and water molecule. Okay, so look at the water molecule H2O compared to CO2. So in terms of state, you look at the water molecule, majority at the room temperature can be in liquid stage, but CO2 at room temperature is in gaseous state. So means that what is the distance between the molecule? Between water molecule, closer, but CO2, not so close. Correct or not? They're far distant. Correct or not? Right? So therefore, in gaseous state. But if you look at the molecular mass, RMM, then you realize that something is not correct there. Why? RMM for water molecule only 18, but CO2 is 44. So means that in this case, if CO2 with 44 RMM larger, they should be in the gas stage. H2O must be in the gas stage. But why H2O is not in the gaseous stage? Correct or not? You look at the molecular size here, 44, means that higher compared to the water molecule. And water molecule, okay, exists in a liquid form. If you use the CO2 as a benchmark, then by right, H2O, it should be in the gaseous form, but no. Then it must have some special property about the water molecule H2O. Okay, so let us zoom into this water molecule. And in the water molecule, you realize that, guys, okay, this is one water molecule, okay, with oxygen atom linked with two hydrogen atom. Okay, right, H2O. So the shape here is something like a V shape. Okay, and we do know that even though H2O is a covalent compound, they share the electrons at the outermost shell. But the problem here is O oxygen atom is more electronegative. So you're going to pull the electron nearer. So that now hydrogen atom seems like lost the electron. So it's a slight charge delta positive. And oxygens have a slight charge of negative. Okay, and because of this, dense water molecule and another water molecule is not only with this what we call the weak van der Waals forces or London dispersion force only, because they have extra types of bond which term as the hydrogen bond. So it means that if you have another molecule of water, this one's oxygen atom, hydrogen atom. So it means O is delta negative, H is delta positive. And because one delta negative, one delta positive, there is an electrostatic interaction. And this electrostatic interactions here is termed as hydrogen bond. Are you clear? So because of this hydrogen bond, you try to imagine that with these extra hydrogen bonds, definitely will make the water molecule close to each other. Can you see that? Close to each other. So means that they are in the liquid form rather than in the steam or water vapor form. Are you clear? Our gaseous stage. Okay. So these hydrogen bonds actually lets the water molecule to have a different kinds of property that we are going to learn now. Now, if you look at the water molecule, so this water molecule, we call them, they are polar. They are polar because delta positive, delta negative. So water molecule can form the hydrogen bond with each other. So now what you need to do, complete figure 3.30 by indicating the slight charge delta positive, delta negative of the water molecule, and then draw the hydrogen bond formed between the water molecule. Okay. Okay, so let us look at how we label it now. So we have done for the first one for you guys. So delta positive for hydrogen atoms, so delta negative for the oxygen atoms. Okay, so same thing, we can do it for this water molecule. Okay, so therefore one delta negative, one delta positive, they form hydrogen bonds. Always remember, hydrogen bonds must, you must use a dotted lines, okay? So again, this is how the water molecule link to each other through the hydrogen bond, okay? So now, indicates here, hydrogen bond. So because of the extra hydrogen bonds, it gives the water many, many special properties. Okay. So what are the special property or unique property of water molecule that we're going to learn? We have 6 here for today. Okay, we're going to look at, okay, water molecule or water, they have high specific heat capacity. They have high latent heats of vaporization, high internal cohesion adhesions, high surface tension, and low density at the freezing point. Means that water is denser than the ice, and they are excellent solvents for ions and also the polar molecules. They are not excellent for the hydrophobic particles. Okay, so that's why we don't use the word universal solvent. If we use the word universal solvent, means that they can dissolve anything in the world, but we don't use the word universal with the excellent. Basically, all ions, and generally most of the ions and the polar molecules, they can dissolve in water. Okay. So now, unique property of water stated here, we have high specific heat capacity, high latent heats of vaporization, high cohesion and adhesions, high surface tension, low density at freezing point, as well as the excellent solvent. So what is so important about these 6 properties for the living organism? Okay, so please link the match it with the respective diagram, at least you know what actually happens here. Okay, so first of all, we look at this, what is meant by high specific heat capacity. High specific heat capacity basically means that the energy required, okay, the amount of energy required, the intensity of energy required to increase 1 kg of water by 1 degree Celsius. Okay, if you want to increase by 1 degree Celsius, that is the amount of energy. Are you clear? So basically, water have high specific capacity. So when you say that water have very high specific capacity, means what? Means that it's not easy to, we need a huge amount of energy to increase it by 1 degree Celsius for 1 kg of water. And this is very, very important, particularly for aquatic organisms. If the temperature can increase, fluctuates very, very huge, okay, what will happen? You're going to cook all the aquatic organism, right? Okay, the sponge box here, okay, right, the petrix here. Okay, why? Because you try to imagine with the sun, the heat energy from the sun. Okay, so water, let's say for example in the oceans, okay, can increase easily. In this case, what will happen? Means that you're going to boil the water, right? You increase to 60 degrees Celsius, 40 degrees Celsius to 60 degrees Celsius in very, very short period of time during the noon times, right? So in this case, you're going to denature the enzyme, you're going to denature the proteins of this aquatic organism. But this thing, no, won't happen, because we need huge amount of energy to increase 1 degree Celsius of water for 1 kg of water, right, by 1 degree Celsius. You try to imagine, definitely you say that, at home I boil water, no problem, right? Definitely, how many kg of water you boil? Correct or not? Okay. Even though we say that, yeah, we boil is quite fast. I mean, 5 minutes. You try to imagine that is less than 1 kg, or maybe about like 1 kg of the water that you boil, and you need about 5 minutes, or about like 5 minutes to boil it, right? 1 kg. But you try to imagine in ocean, how many million tons of water. So definitely the energy that required to increase 1 degree Celsius is very, very huge. Okay, so the first one basically linked to who? Linked to this, the first diagrams on the right. Okay, at the right here, so aquatic organism will be able to survive well. If no, they will be cooked up. You can imagine that their temperature increased 64 degrees Celsius. Okay, now high latent heats of vaporizations is very, very important because it gives us the cooling effect. Okay, so this is very, very important, particularly when we do exercise. Why we sweat? Right, when we feel hot because of thermal regulations, okay, stimulate our sweat glands to release the sweat. And why we release the sweat? It makes us so sticky, smelly. Why we still need to do this? Because the release of the sweat onto the surface and allow the evaporation to take place. And why evaporation take place? Because this water molecule or water absorbs sufficient heat from our body and then evaporate. So they take away our heat energy. So therefore, it makes us having the cooling effect. So yeah, okay, I think I need to change the diagrams now from Li Chongwei to Li Zijia, right? Okay, now never mind, just a quick ones. Next, high cohesion and adhesions. Okay, cohesion and adhesion basically means that the force, okay, or attraction force between water molecule for cohesion force and adhesion between the water molecule with other object. Okay, so this is very, very important for the transportation of the solutes or water from the root to the shoot. Okay, so definitely related. So in this case, you can see that if you use the white flour and you put it in different container with different color, that's how we actually dye the flour. Okay, so the answer is cohesion and adhesions. Okay, so next, high surface tension. High surface tension, basically, if you look at the water, so they seem like got one membrane, they got one layer of the membrane. So this is actually called surface tension. And you place a light object, it will stay float on it. Cranot, for example, some insects, they have the ability to stand on the surface of water. Okay, and if you want to try this, very simple, you take a bucket of water and then you start to slap on the surface of water, you feel pain, right? Okay, or when you dive into the water, why actually you dive in rather than you fall flat on the water, you feel pain basically. Why? Because they have this high surface tension, and this high surface tension is very important because some insect can use this surface as their habitat. Okay, low density at freezing points. Okay, basically at 0 degrees Celsius, you can see that the ice actually floats on the water. Why? Because they have low density. And what's so important about this? If the ice is heavier or denser than water, what will happen? You try to imagine when during the winter, ice form and they are heavier, they are denser, they sink to the bottom. So means that the freezing of the water will be from the bottom up. If the bottom up, then you're going to kill all the living organism inside the river or inside the ponds or inside the ocean. But if the ice, they are less dense compared to the water, they float. When the ice float, in this case, what will happen? It form the insulator. Can I see that? It form the insulation layer. Therefore, the freezing will be from the top down. But the top down process, we have the one layer insulator already, right? So it means that the process will be slower, allowing the aquatic organism continue to survive. Okay, and why water also won't freeze easily? In this case, also due to the high specific heat capacity. Cannot, because high specific heat capacity also means that the reductions of the temperature of the water also need to release. Okay, in this case, want to release more energy. Okay, and last, we talk about excellent solvent. You can see that when we solubilize this sodium chloride, they interact with the ions, making them soluble and allows the chemical reactions to take place. Okay, you're able to get all correct in this case. That is in general. Now let us look at it in detail now. Okay. So when we talk about water has high specific heat capacity. So what's the definition of specific heat capacity? So we say that it's a heat energy required per unit mass to raise the temperature by 1 degree Celsius for 1 kg. Okay, are you clear? Okay, per unit mass per kg. So water has high specific heat capacity because we have the hydrogen bond to absorb the heat without a great change in the temperature. So if without the hydrogen bond, then water molecule, this water, it will have low specific heat capacity. Then that is the fluctuations of the temperature. Okay, so therefore temperature water rise of fall slowly. Organisms are better able to maintain their normal internal temperature. Okay, so habitats such as ocean and lake will have a thermal stability and what's called a thermally stable environments for this aquatic organism to survive. Okay, if no, then we don't have the seafood anymore. Okay, everything cooked for us already. Okay, so next, and our water have high heats of vaporizations. So what's mean heat of vaporization? Heat of vaporization is the energy required to change 1 gram of liquid water into the gas. And okay, so this water, and again, guys, we know that if they are staying as the liquid form, means that the distance between these two, they are short distance. Okay, let me draw it here. If this water molecule, so they have hydrogen bond. In order to make them into the gaseous stage, then we need to break this hydrogen bond. Correct or not? So that to free the water molecule, to make them into the water vapor. So this evaporation process actually absorb the heat energy from surrounding. It can be from us, right? Okay. So during thermal regulation, we sweat. Why we sweat? We sweat so that we will be able to let this evaporation take place, allow us to have the cooling effect. And this cooling effect is known as the evaporative cooling. Okay, so it means that we change the physical stage of the water from the liquids to gas stage. Okay, so evaporation of water from the leaf of the plant or the skin of animal actually remove the excess heat for us. Okay, now next property, we look at cohesions and adhesions in this case. So cohesions, basically, when you look at this word cohesions, means that it's attraction force of water molecule to with another water molecule because of the polar property of the water molecules. Okay, and this will help the transportation of water molecule, okay, against the gravity in the plants, so that the water molecule now move in the long unbroken columns through the vascular tissues in plant, particularly in the xylem. And you will compare what's different between cohesion and adhesion. Adhesion basically means that water molecule attracted to other material, again forming the hydrogen bond. For example, the adhesion force between the water molecule and the plant cellulose cell wall. Okay, so always remember, you look at this diagram. For water molecule to move in the xylem, so they do have the cohesion. Okay, cohesion means that between water molecule and water molecule, so this is a cohesion force. And between the water molecule and the cell wall is the adhesion. Okay, and we do know that if we want for the transpirations to occur, okay, so for transpiration to occur, so water molecule evaporates, correct or not? Out, okay, for transpiration. So creates the tension. Okay, so here low tension, low, this one is high. So therefore, you can see a water molecule move up the xylem or move along the xylem. But the question here is that this process anti-gravity. When anti-gravity, what will happen here is gravity will tend to pull the water molecule down. So if you imagine this case, right? Okay, so you guys walk alone. 3 of you walk alone. If I want to kidnap one of you, easy. I just take it, okay, whole gangs, okay, just drag him into my car. So easy. But try to imagine now, you guys hold hand and you walk. So if I want to kidnap one person, impossible. Because why? You guys hold hand, difficult, correct or not? So gravity again want to pull down the water molecule, not so easy. Why? Because everyone's actually hold hand like this. Okay, form this, or we call the unbroken column, a continuous column of water like this. Okay, so it means that if I want to kidnap one, cannot I kidnap all. But you want to pull everything down, impossible as well, because water molecule also form the adhesions with the cell wall. So it means that if let's say here we have something for this person to grab on it, therefore you can see that it's not easy for me to actually kidnap all of you, correct or not? Okay, So differentiate between this force between water molecule and water molecule is termed as cohesions. Okay, cohesions. Okay, between water molecule and the surrounding, that will call as adhesion. So because of cohesion and adhesions, these two forces, therefore water molecule can be transported inside the xylem, and the process is a passive process. Are you clear? Means that the process does not require ATP. Okay, and water also have a high surface tension, also because of what? Cohesion force. So this high surface tension tends to make the water molecule actually having this, what we call the minimum surface here. Okay, can you see that? This the what we call the force, the cohesion force. Make sure that now this water droplets tends to stay as a round shape. Okay, so the surface tension is a measure of the force necessary to stretch or break the surface of the liquid. Okay, you try to imagine, okay, on the surface, you try to lie flat, okay, you jump it flat onto the, you won't do this, right? What you do, actually, you point your finger in, so you break the tension first, right? When you break the tension, so the diver, can you see that? When you dive into the water, you always break the surface tension. Okay, so in this figure, we can see that water molecule are put together due to cohesions, highlights, okay, it's due to the cohesions, so creating the smallest surface area possible. And then with the smallest surface area, then it creates these tensions. Okay, so surface tension. So next, the water has a high surface tension, allows certain small organisms, for example, the pond skater, to exploit the surface as a habitat. And this is also important. You try to imagine when they stay at the surface, they can become the food particles. Okay, they can become the what we call the the fish can consume on them, can eat them, the fish. So means that it maintains the stability of the food web and food chain as well. Okay, now water is denser than the ice. Okay, so in terms of density, if you look at density, so density actually rho equal to mass per volume. So this thing, actually, you can do the experiment, say later, very simple experiment, but be careful, you don't actually create the problem to your freezer. If not, then your mom may kill you. What you can do, actually, you take a cup. Okay, you fill in the water until maximum. Okay, so this is the cup, until maximum. Then you put in the freezer compartment, let it freeze. After, one day, the next day, when you look at it, then you realize that now you have something like, initially this is the position, but now you have something like extra bumming out like this. Okay, so this is a property of ice. When you can look at ice, when you freeze them at 0 degrees Celsius, they expand in terms of the volume. So when the volume expands, mass remain the same. Correct or not? You didn't add any more water, right? So remain the same. So therefore, density will be lower. So with this lower density, means that it have a higher volume. So means that ice tends to have lower density compared to the water they float. Okay, so what's so important about when the floating, you try to imagine this is the pond. So first, you can see that a thin layer of the ice is formed here first. And then the freezing process will be top down. So the freezing process top down means that the aquatic organisms still can survive. Are you clear? And this will act as the insulator or insulations layer. Okay, so water reach a maximum density at 4 degrees Celsius. So the higher density for the water is at 4 degrees Celsius. So can you see that 4 degrees Celsius of water at bottom, and here near to 0. Can you see that? Okay, so water freeze from top down, acting as insulator to keep the water underneath from freezing. Okay, so you can see that the arrangement, why the volume increase, because the crystal lattice. Can you see that? Crystal lattice, the bond form, so that water molecule now in the very nice order, and this nice order allowing water molecules now, or water, to have the fixed shape, right? Correct or not? If you follow, like basically fixed shape means follow the container, and you remove the container, they still have a fixed shape. Okay, But in this case, when you from this 0 degrees Celsius, change to 4 degrees Celsius, then what will happen here? You can see that it's not really organized well. It's not in their crystal lattice form. So the volume actually decreased. So when the volume decrease, density increase. So therefore, they will sink down to the bottoms. Okay. And this is particularly very important after the winter, when the ice start to melt. So from 0 degrees Celsius, okay, increase to 4 degrees Celsius. So this water going to sink. So 4 degrees Celsius higher density, right? So water sink. So it's going to make a water cycle. Can you see that? The water can cycle. So the cycling of the water here, okay, allows the distributions of the nutrient as well, inside the lake or inside the pond. Last one, we'll look at this. Water is an excellent solvent, particularly for ions and polar molecule, because they can form the hydrogen bonds with the ions and also the polar molecule, particularly OH. Okay? So water molecule cling to the polar or charged molecule, cause them to be soluble in water. Okay, and it's very important where water can dissolve the compound made from non-ionic polar molecules such as glucose and the globular protein, and allow us to transport them throughout our body, through the, for example, our bloodstream, a blood vessel, and also the vascular vessel in the plant. And this allows biochemical reaction to take place, because biochemical reaction always take place in the aqueous medium. Okay, so and also water molecule or water can act as the reactant as well. In this case, for hydrolysis process, photolysis during the photosynthesis. Okay, so with this I've done for this chapter. Okay,